Hi everyone. In this video, I'm going to explain how to sort the given set of elements using selection sort. In the previous video, we discussed how to sort the elements using bubble sort. In the bubble sort, what we did, whatever the elements we taken, in each and every pass, we are finding the largest element and we are keeping from the last. So hence we sorted from the last. That means we find the maximum, we keep at the last. Among the remaining elements, we find the maximum element, we keep it at the last. Again, among the remaining elements, we find the maximum element, we kept at the last. Again, among the remaining elements, we find the largest element and we kept at the last. So like that, we sort the given set of elements by finding the maximum element among the given set of elements and keeping from the last. This is how we sort using the bubble sort. Now, in the selection sort, we are discussing how to sort using selection sort. So, what we are doing in the selection sort, so we are finding the minimum element in and then we are keeping from the beginning. Okay, that means we are sorting from this end. So, whereas in the bubble sort, we find the maximum element we kept at the last. That means from this end we keep sorting. But here entirely reverse, we are sorting from this end. That's it. Okay. So now for that, what I will assume, so first I will select whatever the element stored in the position 0. Whatever the element stored in the position 0. So that I select this position and I will assume whatever the element stored in this position, that is L. So this itself is the minimum. Okay, so that means now I'll assume what? So whatever the element stored in the selected position I, there only minimum element is there. So my I and min both are pointing to 0 index. Okay. So now what I will do, I will start comparing with the next elements. I will start comparing with the next elements from the I. So I will take one more index j to the next of I. So I start comparing whether my assumption is right or wrong. So I compare this element with this one. Now among this minimum element is A of 0 or A of 1. No, now assumption is wrong. My minimum element is not stored in the position 0. Minimum element is stored in the position 1. So what I will do, I will change the minimum position. So 7, 3, 9, 5, 2 as it is. But now this is my ith position and now I'm going to change the minimum position to here. That means minimum element is not stored in the position 0, minimum element stored in the position 1. Okay, so now next I need to compare with the next element. So next j incremented from 1 to now 2. I'm not writing the index in every way. So assume the index is okay, 0, 1, 2, 3, 4 index is like that. So here I, min and j all are indicating the index. So now I'm comparing this a of min with the a of j. Now after comparing these two, now it's confirmed that minimum among these two minimum is 3 only. So that means among these 3 minimum element is 3 and position is the minimum only. So after that, so 7, 3, 9, 5, 2. So my I position, this is my initial selected position. Okay, then this is my min only. So then I am incrementing from j from 2 to 3. So now I'll compare this with this one. So now after that, again it indicates that minimum element is stored in the position 1 only. So I'm not going to change anything. I will keep all the element as it is. So now my selected position initially is this one and now my min position is still in the position 1 and my j I am going to increment to the last position. Now I am comparing this element with the last element. Now after comparing these two, now I came to that minimum element is not stored in the position min or 1. So minimum element stored in the position j. So now I change this position. So now I will write as it is numbers as of now. And then I'm going to see this is my I itself. Now my minimum position is not this one. Minimum element is not stored in this position. Minimum element is stored in this position. Now we checked with all the elements. We stopped. After stopping, we need to, so where we need to keep this minimum element? We need to keep this minimum element at the first position. First position means which position? We marked it as I position. So now we need to change, swap A of I with the A of min. So A of I is 7, A of ith element is 7, min element is 2. So I'm swapping these two elements. Okay, 2 and 7. Okay, so this is becomes 2, this is 7, remaining element as it is. So this is my after pass 1 or round 1. Now after pass 1, what we did, among the given elements we found the smallest element and we kept at the initial position, first position. See, exactly ulta what we did in the bubble sort. In the bubble sort we find out the maximum element, we kept at the last. But here we find out the smallest element and we kept at the first position. So now remaining elements we need to sort. Okay, so which are the remaining elements? 3, 9, 5, 7. Now among these three, now again I need to select. Okay, again, so this is my I initially, and I will assume in this position only what minimum element is there. So next I will assume, so the J, now I have to compare J, this is, now I am comparing this with this one. So now my, after that I came to know that among 3 and 9 minimum is 3 only. So this is only I position, this only is my min position, but I increment J, so J is going to position 2. Now I am comparing this with this one. So now after that, so again 3, 9, 5, 7. So my still my min, this is initial position I, what, and min position is here only. So next I am going to increment J to position the last position, that is 4. So now this 3 I am comparing with 7. So again the minimum is 3 only. So what I will do, I am not going to change anything. I am keeping all the element as it is in this example. So now this is my I and this is my min position. So what we did here, we swapped what? Ith element and minimum position. Here also same thing, we are swapping ith element with minimum, is both are same. I am swapping 3 with 3. So that means now I found the second minimum element and we keep at the second position. So now this is at the end of what? Pass 2. That is after cycle 2. So after pass 2, we got 2 elements are sorted. Minimum, first minimum is stored at the first position. Second minimum is stored at the second position. And now remaining elements is these 3. Now again the same procedure we will start. So I will select the ith position and I will assume in this position only min element is present. I will assume. Next I will not to confirm, I am going to compare with the remaining elements. Now this minimum element I am comparing with the jth element. Among these two, which is minimum? So jth minimum. So I will change the minimum position now. Now earlier this is my minimum position. This is my I, this is my min position. Now I am changing min position to here. That means minimum element is 5. So I am changing the minimum position. So now after that I am incrementing the J. J comes to the last position. Now again I am comparing these two. So among these two, 5 itself is the minimum. So I am not changing anything. So I am keeping everything as it is. So I here, this is only the min. Now what I have to do, I need to swap ith element with minimum position. What I did here, ith element and min position, after comparing all the elements, I swapped I and min position. Here also ith element with min position. Similarly, I need to swap these two. So after swapping, I got 5 here, 9 here and 7 here. So this is after the pass 3. So after pass 3, what I got? Third minimum element we got, and I stored the third position. Okay, now we got what? 2 elements are remaining. So which are those? 9 and 7. Now same procedure, I will start selecting here and then I will assume this itself is the minimum element is stored in this position and I will compare with the next element J. So when compare this, I came to know that minimum element is not stored in ith position. Minimum element is stored in which position? Jth position. So I changed. So now this is the after pass 4. After pass 4, so now what we have to do? We need to change, swap what and what? ith element and the minimum element. So I got 7 and 9 here. So I got fourth minimum. So actually this is my pass 4. So now we left out with only what? One element. One element. So that itself there is a starting. So finally what we are having, if you observe here, see from the 0th position. From the 0th position what we are having? 2 I am having. So I am writing 2 here. So and then from position 1. From position 1 what I am having? 3 I am having. And from position 2. From position 2 what I am having? Finally I am having 5. So this is 5. And position 3 what I am having? Position 3, right, I am having 7. So in the last position, 4th position, what I am having? Finally, if you observe here, 9. So thus my array is sorted. Okay. So now we will write algorithm for this. Okay, so I have given the name selection underscore sort, and parameter to be passed is the array to be sorted. So array, so here in this example we taken 5 elements. Always we'll sort 5 elements? No. In general we are sorting n number of elements. So if I take 5 elements, last position is 4. Similarly, if I take 10 elements, last position is 9. So if I take n elements, last position is n minus 1, and always we started with the first position 0. So arrays, that means arrays in general we are writing some arrays without giving any values. Array from position 0 to n minus 1. Now here, what and all the things we did here in our algorithm. So first what you see. So in order to pass 5 number of elements, we did pass 1, pass 2, pass 3, pass 4. Okay, pass 4 we did. So in order to sort 8 elements, we need pass 7. In order to sort 10 elements, we need 9 passes. So in general, we need n minus 1 number of passes. But in each passes, we compared, right? So compared. Like that we compared, we repeated. Okay, here 2 things we are repeating. So one is we first we selected position 0 na. First is I selected position 0. Next I selected position 1. Right. Next I selected the position 2. Next I selected the position 3. Next I selected the position 4. Okay, like that in each and every, okay, here. Okay, so in each and every pass we are selecting what? Some positions, right? Positions. So for that, since we are selecting the positions, so that we are repeating. From where we are repeating? If we observe, see we started selecting I is equal to 0. So then we selected I is equal to 1. And then we selected I is equal to 2. And then we selected I is equal to 3. Right? But we are not selected this one. Last one we are not selected. Last one we are not selected. See, I will show you once again. So we started with what? I is equal to 0. We selected this one. So then we selected I is equal to 1. So then I selected I is equal to 2. So then I selected this position I is equal to 3. But then we have not selected this one. We only one element. So we stopped. So we stopped at where? I is equal to 3. For 5 elements we stopped at 3. For 6 element we had to stop at 4. With 8 elements we have to stop at 6. So for n elements we are stopping not in the last position, last but one per element we are stopping. So I am using the for loop. For I am using I as index. For I we start from 0 and we up to 0 to what we did, up to n minus 2 we did exactly. Here there is not really, you have to do this one. Okay, 0 to n minus 2. So that means selecting means what? After selecting what? In the same position I, we assume minimum element is also there. So whatever the value of I, that only I am storing as min. That means both I and min are same point at the same position. So I will write min is equal to I. Now after that what we did, we start comparing with the j. I started comparing. After that just compared. So for comparison, I am taking the variable j index. So now where j is initially pointed, position 1, where I is 0. So initially I is 0, j is 1. If you observe here, I is 1, j is 2. If in this cycle, I is 2, j is 3. Here I is 3, j is 4. That means in all the examples, see, j is in front of I, j is in front of I, j is in front of I, j is in front of I. Okay, j is in front of I. So in always j is front of I. So I am using for j is equal to In front means I plus 1. In front of I means in I plus 1. To where, see, we started comparing this element with this element, then this element, till the last element. So observe here, I started J here in front of I, compare this element, compare this. See, we compared till the last. So last element position is what? N minus 1. Up to that, what we have to do? Now we have to write for the comparison. If A of J is less than A of min, I am assuming what? Ith position minimum element is there. Suppose in jth position minimum element is there, what we change? See here, we assume minimum element is there in the position 0. After comparison, we came to know minimum element is not position in I, element is there in the jth position. So I change this min, right? So now it is that suppose if a jth element is minimum, so I need to change the position min as j. Okay, so end for that means after checking in the all the compare elements in the one pass, then after coming out of this pass, that means after coming out of this for loop, now we have to do what? So at the end, what we did here, we swapped ith element with min element. We swapped ith element with min element only. So we swapped ith element and min, see these two, 5 and 9. Ith element and min element. So we swapped ith and min element. So that means we need to swap A of I and A of min. So then end of for. That's it, the algorithm.